All right, for checkpoint 23, on this first question, you typed in the right answer. 1.6 is correct. You probably took your average, which they gave you, and subtracted it from each one of these numbers, and then added those together, divided it by total number of dots to get your mean absolute deviation. Do you want me to go through this one? I can if you would like. All right, so the second one, all right, on the second one here, you also got this one correct. Wow, it's the same answer. Interesting. So this question told you that the average daily temperature was 40 degrees, and we wanted to know what's the mean. So you probably took the average, subtracted it from each one of these data points, added those together, divided it by total number of dots. Would you like me to go through this one, or are you okay with skipping it? Skip. All right. So third one. All right, here we have these two different dot plots, and it says that the following dot plots show the number of hours spent on homework each week for a group of randomly selected students and the number of hours spent playing sports. Which statement best compares the two data sets? And we are to select 3 that apply. I'm going to take a screenshot of this so I can move it over here so we can still see the... Oh, wow, that's a lot of answer choices. Let me zoom out one. Okay, here we go. So here's our dot plot, and we want to pick 3 of these that would be true. So the first option says that the spread of hours in each data set is about the same. Well, looking at the dots and the order that they're in, I wouldn't say that they're about the same. They're definitely different, right? More people... Here we have 4 dots on 2, and here we have no dots on 2. So they're definitely different. It says, the next one says there are very few hours in common. Well, I don't necessarily know if I would say that one is true, because there's 2 dots above 6. Actually, there's 3 dots above 6 here. There's 3 dots above 6 here. I would say they're pretty common. The next one says that the spread of hours spent on homework is much greater than the spread of hours spent on playing sports. So when it's talking about the spread, it's talking about kind of the display of numbers. For homework, there's about 2 dots above each of these numbers. And for sports, there's not 2 dots, but they're spread about the same. This one goes from 2 to 8, and this one goes from 3 to 9. So the range of both of these data sets would be the same. 9 minus 3 gives me 6, and 8 minus 2 also gives me 6. So the spread of the hours is pretty good. It's about the same. I would say I agree with that one. So this one, it's not much greater. I would say they're equal. The next one says that the average student spends the same amount of time on homework and sports. I don't know. Let's come back to this one. We might have to do some work for that. The average student spends more time on homework than playing sports. We probably have to find the average here. The spread of hours spent on playing sports is much greater than the spread of hours spent on homework. Nope. There are quite few hours in common in both data sets, and the average student spends more time playing sports than on homework. So let's find the average for both of these sets of data. To find our average, I'm going to add all of these together. So there's 2 dots above, above 3. I'm going to start with homework. So 2 dots above 3, 2 dots above 4, 2 dots above 5, 3 dots above 6, 2 dots above 7, 2 dots above 8, and 2 dots above 9. So we have 90, and dividing it by the total number of dots. So this is 4, 6, 8, 10, 15. And then let's find the average for sports. Would be 66, and I'm assuming we're also going to divide that by 15. 15, yes. So average for homework is 6, and the average for sports is 4.4. So knowing those two averages, which category has more time spent? Is it homework or is it sports? Homework, right? So the average student spends more time on homework than playing sports. That one is true. And then give me 1 second. So if we look, both of our numbers are primarily between 2 and 9, right? Both of these numbers on the bottom are between 2 and 9-ish, right? There's no 2s here and there's no 9s here, but the bulk of them are in the center. So there are quite a few hours that are in common for both data sets, right? 6 has 3 people spend 6 hours on homework, 3 people spend 6 hours in sports, 5 people spend 2 hours on homework, 5 people spend 2 hours on sports. And then there is one other one, which would be that the spread of hours is about the same, which is this very top one. And like I said before, the spread is about the same because their range is about the same. Well, their range is the same here. The range for this data set would be 9 minus 3, which is 6. And the range for this data set would be 8 minus 2, which is also 6. So the 3 that you'd want to pick here are the spread of hours in each data set is about the same. Where's the other one? The average student spends more time on homework. And there is quite a few hours in common for both data sets. So let me know once you have all 3 of those, and then we can go on to the next one. All right, number 4. All right, for number 4, it says that the following dot plots show the height of players for 2 different basketball teams. Which of the following statements best compares the 2 data? Select 2 that apply. Okay. Let me zoom in a bit and then I'll take another screenshot so we can see the data over. Okay, so let's see. For the questions that are talking about variability, variability is asking you how much your data differs, meaning if I have a data set that the first or smallest number is 2 and the largest number is 91, and then I have another data set where the smallest number is, say, 31 and the largest number is 51, this top data set would have a greater variability because the numbers are more spread apart. This bottom one would have a less, or I guess a least great variability because the numbers are closer together. So when we look at the numbers in these 2 dot plots, our lowest number here is at 68 and our highest number is at 75. Our lowest number here is at 62 and our highest number is at 75. So which team would have a greater or lower variability, or do you think that they are about the same? They're about the same. I would agree with you. Yes. Since there's only this one point way out here at, on 62, this is kind of like our outlier. We can kind of just ignore it. And without that one point, both of the teams would have heights between 68 inches and 75. So I agree with you. The variability is about the same for both teams. And as far as heights go, there are some heights that are in common between the two teams. So there are some heights in common between the two teams, and the variability in heights for both teams is about the same. So those would be our two answers. All right, number 5. So 5 says the following dot plot shows the number of hours spent on homework each week from a group of randomly selected students. If the average number of hours spent on homework is 6, what is the mean absolute deviation for this data set? So to find our mean absolute deviation, we need to take our mean, which is 6, and subtract it from each one of these numbers on our dot plot. Right, so I would do 6 minus 3 twice because there's 2 dots above 3. 6 minus 4 twice because there's 2 dots above 4, and so on. With 6, there are 3 dots, so I'm going to subtract it from 6 3 times. I might have to come up here. And I'm going to flip order. And then we just want to go through and subtract all of these. So this would be 3, 3, 2, 2, 1, 1, 0, 0, 0, 1, 1, 2, 2, and 3, and 3. Okay. So now that we have all of these new data numbers in red, that's how far apart each one of our points on our dot plot is from our average. We want to find the average of all the numbers in red. So we need to add all of them up and then divide it by the total. Now, those zeros here, technically, if I were to add in 3 zeros, it doesn't change what my answer is, but the zeros are important because they're still a part of our data set. So when we are dividing at the very end, we need to make sure that we include those 3 zeros as our total number of numbers that we're adding together. So when I add all of them together, I get 24. Whoops. Very different number. There we go, 24. And I added 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 numbers together. So when I do 24 divided by 15, I get 1.6, which means that my mean absolute deviation here is going to be 1.6. All right, next one. Number 6. So on number 6, we want to know the following data set shows the number of siblings randomly selected in 2 different classes. Which of the following statements best compares these 2 classes? So we have these 2 classes, Class A and Class B. And we want to pick 2 of these that apply. So the first one says that the mean for the number of siblings is the same for both classes. The mean for the siblings is greater for Class A. So what we need to do here is figure out the average for both of these. So let's see, for Class A, I have 2 1s, 1 2, 2 3s, 2 4s, 1 5. So I'm going to take 23 and divide it by 1 2 3 4 5 6 7 8 because I have 8 dots in Class A. And for Class B, I'm going to add up all of these. Gives me 23 as well. And when I divide them by 8, because that's how many dots there are, again, I get the same. So the average for both of these, or the mean for both, is going to be the same. And The average number of siblings is about the same for both. The variability is about the same for both classes, and the variability, so variability is talking about mean absolute deviation, but we could also eyeball the variability based off of these two dot plots here. If I look, the range of both of these is the same. 5 minus 1 is 4. And again, 5 minus 1 is going to be 4 here as well. So that means that the variability is going to be about the same because the range of both of these is the same. So the mean for number of siblings in both classes is the same, and the variability for both of these is also going to be the same. All right, number 7. Number 7 says that the following dot plot shows the June and October electric bills for households in a particular neighborhood. Which statement best compares the two data sets? So we are talking about the average. Okay, so what we would probably want to do here is find the average for both June and October. So to find the average, we're just going to add up all of our data sets. So I have 3 dots above 120, so I'm going to add 120 3 times. I have 2 dots above 130. I'm going to add 130 2 times. I have 2 dots above 150. I have 3 dots above 160, 1 above 170, and 1 above 180. So that gives me 1750, and I'm going to divide that by how many dots I have for June, which would be 5, 10, and 12. Now let's figure out the average for October. I have 2 dots above 90, 1 above 110, 3 above 120, 1 above 130, 3 above 130, 1 above 150, and 1 above 170. So that gives me 1520, and I'm going to divide that by the total number of dots that I have for October, which would be 5, 10, 12 as well. So it looks like my average for June is going to be around 146, and my average for October is going to be around 127. So when I look at the answer choices here, the average electric bill is going to be higher in June. So the average electric bill is going to be higher in June. So that is these two down here. And then we need to talk about variability. So variability is how far apart the numbers are, or which one has a larger disperse of numbers. And that would be October. October, the lowest is 90 and the highest is 170. So that means that since I have a larger spread of numbers, that October would have the larger variability. So the average electric bill is going to be higher in June than October, and the variability is much greater in June than October. Oops, sorry. I was double checking this. So this one goes from 120 to 180, and this one goes from 90 to 170. So if I were to subtract those to get my range, this would be 60. And if I were to subtract these to get my range, 170 minus 90 would give me, what is that? Around 80. And if you look at the dispersion of these numbers, majority of the numbers are going to be between 120 and 160, which means that the variability is actually going to be the same. So this would be the correct answer, this one here, where it says that the average electric bill is higher in June and the variability is going to be about the same. Because the numbers aren't actually that different. Sorry, that was my bad. I was overthinking it. Number 8. All right, 8, we have this following table that shows the mean and mean absolute deviations for heights of women and men's basketball teams. Which statement best compares the two data? We want to select 3 that apply. So let me take a screenshot of this table so that we can see it when I scroll down here. So again, we are picking 3 of these that apply. So the first one says there are few heights in common for the 2 basketball teams. Well, I would disagree. I think that there are many heights in common. So I would say there are many heights in common for the two basketball teams. And the reason why is because our mean absolute deviation is almost exactly the same, right? One of them is 2.3 and the other one is 2.2. Almost the same exact mean absolute deviations. So I would definitely say that they are almost the same. Let's see. The next one's talking about the average. So average is another word for mean. So it looks like the average for men's basketball is taller. So the men's basketball team is greater than the average height of women's basketball team. So that is the second one. Let's see. The spread of heights is about the same for each team. So we want these two. And there are a few heights in common. So for this one, we actually want 3. Again, I apologize. There's not many heights in common because the mean is much smaller. I was thinking of variability. The right answer for this problem should be these 3 that I have highlighted here. So there are few heights in common because the averages are different, but the spread is about the same because the mean absolute deviation is almost the same. Next one, number 9. So again, we have this these 2 June and October data sets again. And this time it tells us that the average electric bill in June is 146 and the average electric bill in October is 127. And the mean absolute deviation is about 18 for both of these. We want to know which statement best describes the difference in the mean electric bills for the 2 months. Okay, so to do this one, we would take our means and subtract them. So 146 minus 127. Oops. And that gives us 19. And we are going to take that 19 and we are going to divide it by our mean absolute deviation, which is 18. And when I do that, I get pretty much 1, right? That's almost 1. 19 over 18 is about 1, which would mean that they are approximately 1 mean absolute deviation apart. Right, number 10. All right, number 10. So here we have a new table, and it's the means and MADs for the different bills for October and June. And we want to know which statement best describes the difference in the mean electric bills for the 2 months. Okay. Well, I mean, let's see. The difference between the means is about 3 times as great as the MAD. Well, no, because if I were to take the difference between the means, if I take 146 and subtract it from 127, I get 19. And if I do 10 times 3, that is not 19, that's 30, so not that first one. The difference between the means is less than twice the value of MAD for each data distribution. So if I take 10 times 2, that's 20. 19 is less than 20, that works. 9 times 2 is 18. And 19 is not less than 18, but it's close. It's almost exactly the same, right? So the difference between the means is a little less than twice the value for the mean absolute deviation for each distribution. So if I were to double my means and subtract those are the 2 numbers I'm comparing. So I'm comparing 20 to 19. 11. So on 11, I have these 2 dot plots talking about the number of books read by students in groups A and groups B. We want to know how much greater is the mean number of books read by group B than the mean number of books read by group A. So we just need to determine, well, what is the average of both of these? So I'm going to take a screenshot to help me do this quickly. So for group A, let's figure out my average. So I have 1 dot above 6, 2 dots above 7, 2 dots above 8, 3 dots above 10, and 2 dots above 11. 88 divided by, let's see, that is 10 people. So 8.8. So group A, my average is 8.8. Let's figure out my average for group B. So I'm going to have 1 dot above 6, 1 above 7, 2 above 8, 3 above 10, 2 above 11, 1 above 12, and 1 above, not 15, but 14. So 107, and I'm dividing it by 4, 5, 6, 7, 8, 9, 10, 11. There's one more in group B, correct? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes. So when I do that, I get 9.7, which means, so we want to know how much greater is the mean of books read in group B. So when I subtract these, 9.7 minus 8.8, let's subtract those. I get 0.9. So correct answer for this one would be 0.9. So 0.9. All you had to do was find your average and then subtract them. Number 12. All right, so we have these 2 dot plots. We want to know how much greater is the mean words typed in group 2 by the mean of words typed in group 1. So again, this is going to be the same exact process as the one before. We need to find the average of both and then just subtract them. So average of both and then subtract them. All right, so that's 600, and we are going to divide it by the total number of dots, which would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 16. Yeah. And then let's find average of group 2. So 20 plus 20 plus 30 plus 30 plus 30 plus 30, 40 plus 40 plus 40 plus 40, 50 plus 50. There we go. So we have 660, and we're going to divide that by, let's see, that's 10, 16 again. So we get 41.25, and here we have 37.5. So to figure out the difference between our averages, all we need to do is subtract them. So a lot of this is just calculator work. So final answer for this problem is going to be 3.75. Oops, that's a weird 3. 3.75. 3.75 is what we want to put for this one. 13. Oops. We want to know what is the difference between the two means. So again, we're going to find the average for a number of pizzas sold during each week. Sorry, I accidentally minimized my tab. There it is. And then once we do that, we are going to subtract them. So number of pizzas for week 1. So 24, I have 2 dots above 28, 30, 32, 36, and that last one's a 37 because it's in between 38 and 36. This last dot here is 37. 215 divided by 7, I have 7 dots. For week 2, I have 26 plus 30 plus 32 plus 34 plus 34 plus 36 plus 39. That gives me 231, and I'm going to divide that by 7 again. So I have 33 minus 30.7, which gives me 2.3. So average for this problem is going to be 2.3. So 2.3. Cheesy pizza. 14. Almost done. 2 more. All right, on 14, so I have that homework and sports dot plots again. And it tells me that the average number spent on homework is 6, and the average number of homework spent, or the average number of hours spent on sports is 4.4. Which statement best describes the difference in terms of mean absolute deviations? So what we would need to do here is first of all, we would need to figure out our mean absolute deviations. So to do that for homework, since actually I think did we already do this one? We did. So our mean absolute deviation for the one with sports, so mean absolute deviation is going to be 1.6. And our mean absolute deviation for homework should be this second one. Nope. Was it 5? Yes, this is the homework one. So mean absolute deviation for homework, what did you get for this answer for 5? Help me out here. We should have gotten 1.6, perfect. So since our mean absolute deviations for both of these are the same, when I subtract these, 6 minus 4.4, 6 minus 4.4 is 1.6. And since our mean absolute deviation is 1.6, they are one mean absolute deviation apart, right? The distance between our two medians is 1.6, and one mean absolute deviation is 1.6. So the difference in means is about one mean absolute deviation. And last one. So here we have the women and men's basketball team heights again. And we want to know which statement best describes the difference in terms of the mean absolute deviation. So mean absolute deviation is about 2.2, right? And we know that the means are 76.3 and 70.5. So like that other problem, we're going to start by subtracting them. So I'm going to take 76.3 and subtract it from 70.5. That's going to give me 5.8. Now my mean absolute deviation is about 2.2. So let's take that 5.8 and divide it by 2.2, and I get 2.6. So when we look at our answer choices here, it says that the difference between the means is more than twice the value for mean absolute deviations. Well, 2.6, 2 is another word for twice, right? If I multiply something by 2, that is twice. And 2.6 is greater than my mean absolute deviation. So for this one here, it should be this, the difference between the means is more than twice the value of the mean absolute deviations for each distribution set. And this one here is the last question.